Good morning everybody, and once again welcome back to the channel. In today's video we are going to be building a Spark streaming pipeline which reads data in a micro batching fashion from a Kafka topic, and it performs a merge into on the new Amazon S3 table buckets. After every micro batch, the offset is committed in the checkpoint directory, so in case of the Spark structured streaming job fails, it should resume from that particular point. So what are you waiting for? Let's get started. All right, so the first step is we need the infrastructure. We can spin up that with Docker Compose. So we're gonna need Kafka, Zookeeper, so we're gonna spin that up. Here is the project repository. You have following folders. Consumer is where you will have the Python, PySpark, Kafka consumer. And then you have a producer and the Docker Compose file. So the first step is Docker Compose up -- build. This will spin up Kafka and Zookeeper running locally. So let's give it a couple of seconds, and hopefully that should, as you can see, all the containers are now up and running. So now open up Chrome and then head over to localhost 8080, I believe. And then here you will see your Kafka cluster, and it should be in the online mode. All right, so the step 2 after that is let's publish some messages into the Kafka topic. So inside the project repository, you will have a folder called producer. Let's head over to the producer. So I am already inside that. And here you have publish Kafka message.py. So I'm going to say Python 3 publish Kafka message.py. And this will publish like a lot of messages on the Kafka, as you can see, right? So I'm just publishing a bunch of messages. And then head over to localhost 8080, refresh, go to the topic section. You will see a topic appearing shortly here called customers. So let's wait. As you can see, customers. If you go to message, you should be able to see that particular message. So step 2, publish some messages into the Kafka topic. All right, so the third step is we need to take a look at the PySpark streaming consumer, right? Which is going to ingest data from the Kafka topic. I'll give you an overview of this particular code, what it does. So let me move this one here and then do this. Okay. So I have 3 classes, right? I have Avro schema, merge query, and the Kafka stream processor, right? And then I have a function called parse arguments. This is where you will pass a list of arguments, right, to the job, right? And then I have a main function over here, as you can see. So the first thing the job does, it creates a Spark streaming job, as you can see over here. Hopefully, if I can expand everything here, right? So spark.read stream, and then all the arguments that you pass, they are gonna be set over here, right? Such as the bootstrap URL, the topic from where you want to ingest it, the max offset trigger, etc., etc. So all these items are gonna be set, right? It's gonna create a stream object. And then what it does, it basically for each particular micro batch. So let's say you said, hey, you want to run every 15 minutes or every 5 minutes or every 30 minutes, depending upon your cadence, right? A process batch function is invoked. If the batch count is greater than 0, right, it will deserialize the Kafka message based on the Avro schema that you provide, right? And after deserializing, it will execute a method called execute merge, and this is just gonna execute the merge query. So the incoming batch data frame, it creates a global temp view called source data. It executes the merge command, and then it basically releases or destroys the temp view. Okay, so the code is that simple. Okay. All right, now let's see how to fire this, right? So before that, here you can see is my merge query. So I merge into manage catalog.default.employees, right? This table does not exist. We are gonna create that table shortly. And then if the condition is matches on the employee ID, we want to update. If it doesn't match, we want to insert. So this is as simple as a job, right? So now let's create a table first, because we need to create that Iceberg table first. So in the create table and query folder, I have a very simple Python code which will create an Iceberg table. If I expand here, so I set all the bunch of columns and their appropriate data types, right? So now let's create the table, right? So if you go to the notes section, right, here I have a command, right? Simply replace your table bucket ARN over here, right? And of course your script path over here, right? So I will run this. This should create an S3. This should create and manage Iceberg for me. So if I refresh here, I do not have one. So I'm gonna go to my notebook. I'll fire the Spark submit command. Okay, it's complete. I refresh my S3 tables. I can see a table called employee in the namespace default. So go ahead and create a table, and now we're gonna be running our Kafka consumer. So now we're gonna be running our Kafka consumer. Okay, so let's take a look at that. I have the command. All you need to do is replace your table buckets ARN, right? So let's see, Spark submit, we are running it locally. We give a 1 G of memory, right? The name is gonna be Kafka batch processor, right? And then here I pass all the list of configuration. These are catalog implementation, etc. The list of all packages over here. This is the path to the script file, the Python script, right? Bootstrap URL is going to be localhost 9092. Topic is going to be customer. Offset is going to be earliest because we want to start from the earliest. This is going to run every 5 minutes. The max offset per trigger is how many message you want to grab, right? This you can, it's just a knob that you can configure. This is the checkpoint directory and the path to the merge SQL. Okay, so let's see if I can run this, right? So in theory, if I copy and if I paste this here, and at an interval of 5 minutes, this is gonna grab a micro batch and then it's gonna do a merge into command into that our manage iceberg table. So this is running, as you can see, every 5 minutes, it's gonna grab all the micro batch and then it's gonna do the merge into. So it is running. So now on the another terminal, I again have a Python file called query this particular table. So here you can see query table, and this will basically do select star, right? So we can also do a count, so we know that if those records are they made it into the iceberg, right? So let's just do count star, and then I'll copy the path again, head over to my terminal, Python 3, and it should, and again I should be able to query that, right? And on my first terminal, the micro batch is running every 5 minutes, and here I am also able to query that, right? So my as you can see, right, 5 6 messages are there inside that particular iceberg table, right? And as you can see, now I can publish more messages here. Let me just quickly do that. Python 3 publish. So I'm adding more and more messages into the Kafka topic, as you can see. Now every 5 minutes, once the interval is done, it's again gonna grab the new micro batch and it's gonna do the upsert, right? And then if you see locally in the checkpoint, you see the offset, right? If I just basically come here, offset, here you can see, right, the offset also has been committed into the checkpoint directory. So in case if the job fails, right, it should resume from this particular point, my point being. So yeah, I hope you have enjoyed. I will leave all the resources and code materials on my GitHub, so you can try, check it out, modify if needed, right? But hey, it works flawlessly. You can try it out. You can also deploy this on EMR EC2 or EMR serverless, however you like. That's all I have for the video. Thank you so much for watching. Keep smiling, keep programming, and I'll see you in the next video.